This is AP Physics FRQ question that was posted on College Board for the students to prepare for AP exam. So let's read the question and look at what is given. Passenger compartment of a rotating amusement park ride contains a bench on which a book of mass MB is placed as indicated by the dot on the left figure above. So on our side, it's right side. The compartment moves with a constant angular speed about the center of the ride along a circular path of radius r. The bench remains horizontal throughout the compartment's motion. The right figure above shows a magnified view of the compartment. The graph below shows the horizontal x component of the book's position as a function of time, where the positive x is the direction to the right. Determine the period of the revolution of the book. Calculate the tangential speed VB, velocity of the book, not the angular speed of the book. If I look at my graph, I see that the motion of the object starts to the left, to the right, and back down to the same original position. So that is the full revolution all around the circle and coming back to where it used to be. So it went from the same position to the same position. And it looks like this time is 120 seconds. Each increment 1, 2, 3, 4, 5 makes 100. So that means each one of them is 20. So I have the time, the period it takes to go around the circle is 120 seconds. In order to calculate the velocity of the object or the book moving around a circular motion, I need to figure out the radius because I need to find the distance. So the velocity is going to be equal to the distance over the time, and I just found the time, how long it takes to go around the circle. The distance is 2 pi r, the circumference, over the time, which is the period. And the book goes from its equilibrium this distance up and this distance down. So the book goes this distance down and this distance up. So that looks like the radius of the motion is equal to 30 meters. So now if I plug in this into my equation to calculate the velocity, I have velocity is equal to the distance, which is 2 pi, and the radius is times 30, divided by the time, which is 120 seconds. That gives me 4. And if I divide 2 pi by 4, that will give me 1.6 meters per second. For D part, they ask, on the dot below, which represents the book, draw and label the forces, not the components, that act on the book at the lowest point of its circular path. Each force must be represented by a distinct arrow starting on and pointing away from the dot. And then for the second part, they ask you, at the lowest point of the circular path, the book is moving only in the horizontal direction. In what direction, if any, is the net vertical force on the book? So at first I'm going to go look at the graph where it was at the beginning and look at the forces. So the book always stays on the bench and doesn't move anywhere. So the forces acting on the book would be mg and the normal force. So I can say that the forces acting on the dot to show the forces that are acting on the dot. It's the normal force and mg. Now, at the lowest point of the circular path, the book is moving only in the horizontal direction. In what direction, if any, is the net vertical force acting on the book? So if the book is moving in this direction, so that would be the velocity, then the net force is acting toward the center, and it is centripetal force. Otherwise, the book would not end up in every single position where it ends up in the circular motion. So the net force acting on the book is up. For part C, they ask you to find the algebraic equation for the vertical force that the bench exerts on the book at the lowest point of the circular path in terms of the book's mass. So we can use the mass for our expression. Tangential velocity and the radius of the path, and physical constants as appropriate. Do not substitute any numerical values for variables or physical constants. So I can look at the book on the bottom of the path, and I have forces acting on it. The normal force and mg. And also there is centripetal acceleration. It's a circular motion. So I have the net force is equal to mac, and ac is up, so it's a positive. The net force is the normal force minus mg equals to mac. So if I solve for the normal force, I have the normal force is equal to mg plus mac is v squared over r. So the normal force is equal to mg plus v squared over r. And that would be your solution. And for the last part, for D, at the lowest point of the circular path, is the force that the bench exerts on the book greater than, less than, or equal to the weight of the book? So here is the bench, and here is the book. Normally, without any circular motion, you would have mg and the normal force. And in this case, without the circular motion, N would be equal to mg. So the bench would exert on the book exactly the same force. But our situation has circular motion, so there is centripetal acceleration. And that changes by how much the force of the book is pushing on the bench, and the bench is pushing back with that same force. So your normal force at the bottom is not equal to mg as if it would. It equals to mg plus mv squared over r. So from here I see that the normal force at the bottom is greater by this much than if the book was just laying down on the bench. So the answer would be greater.